This Roby wash light is a good example of a device which could utilize the functions of multi-circuit lighting devices. It has three concentric arrays of LED emitters, which can change colour independently of each other and can produce some interesting visual effects on the open face of the instrument. To translate that into a multi-circuit lighting instrument is relatively straightforward, but can take a little time depending on what level of detail you want to go to. I have marked out 3 2D concentric circles and 3 2D loci. The loci are going to represent the insertion point of each of the 3 symbols that will make up the final multi-circuit lighting instrument. With the active class being Lights 3D, which is what I will use to create the 3D geometry, I activate the Polygon tool in the Fill mode and create 3 filled polylines. Then I select all 3 of them and run the Extrude command and give those a thickness of -80mm. This means that the extruded geometry will be made in a downwards direction. These 3 polygons are now all grouped together as one extrude. To separate them into 3 again, just run the ungroup command. Now place a 3D locus at the centre of the objects and give it a Z value of -40. Go to a left isometric view to check that all is looking OK. To help with making this object, I have given the default instrument texture some transparency, which I will change back to solid when I'm finished. The next thing to do is go to a front view and create the distance needed between the geometry I have just made, which represents the body of the lighting device, and the insertion point of the device, which is always going to be where the fixing point of the final lighting device will be. The distance I would like to add between these 2 points is 240mm, so I select the locus and the 3 extruded objects and use the Move 3D command from the Modify menu. When that is done, you should go back to the left isometric view. Now I need to make the symbols that will eventually comprise the inside of the moving light. So I select the inner ring first, along with the 3D locus point. This single point will define the tilt axis of the body of the light. I'm also going to select the 2D geometry as well, and then run the Create Symbol command. I'm going to name the symbol Cell 1 and specify an insertion point with the next click of the mouse. The other thing to make sure you have checked is the Change 2D Objects from Layer Plane to Screen Plane. This will ensure that the 2D circle is placed in the 2D component of the symbol. Click OK and very carefully specify exactly where you want the insertion point to be by snapping to this locus. I have set up a specific folder for these symbols, which is named Multi-Cell, so I specify that here. And then, when I click OK, the symbol is made. I then repeat this process twice more, being very mindful of picking the correct insertion point of the symbol each time. It is this point that will locate the insertion point of any label legends that are used with this device. Now I need to attach all the various records to each symbol. So select each one of the symbols in turn and run the Attach Record command from the right-click context menu and select the Light Info record. You can often use the Attach Records command from the Tools Records menu, but it won't work in this instance because the symbols are already placed in the drawing area. Now select all three symbols and change them to the None class. This is good practice, especially if you are unsure of what class a symbol needs to be assigned to. Then make sure that it is only the symbols that will comprise the final object you are going to make, and run the Create Symbol command again. You need to name it according to how you name your instrument symbols. Specify the insertion point and store it wherever you need to in the Resource Manager. You can now delete the symbol from the drawing area. Before I add this symbol as a multi-circuit lighting device, I should add the light info record to it. Now, when I double-click on the symbol definition, the lighting device tool is activated and the multi-circuit lighting device can be placed in the drawing area. You can see that the three cells are now available in the lighting device. And if I run the Spotlight numbering tool, the label legends are lined up properly on the insertion points and are numbered correctly. If I go to a side view of the lighting device, you can see the body geometry suspended under the insertion point. And if I run the Focus Lighting Devices command, you can see that the beam is emanating from the correct point. But when I complete the command, nothing changes. This is because the tilt function is looking for a body part record in the three nested lighting instrument symbols. So you need to add that to the geometry of the symbols. So go to each one of the three nested symbols and select the geometry that comprises the body and attach the parts record to it. Then just check the body field. You can save a few clicks by directly editing each symbol in turn without needing to press the Exit button. When you finish though, click on the Exit Symbol button and the lighting device will immediately update with the tilt information you specified earlier. For now, there's not going to be any pan function until you add some pan geometry to one or all of the three nested symbols. So for the purposes of testing this prototype symbol, I'm going to create a yoke using a simple NURBS curve. So go to a front view and activate the NURBS curve tool. I'm going to make sure that the curve degree setting is set to 1, which will ensure that each segment is linear. And then draw 4 points around the body geometry to indicate for now where the yoke could be placed. Then add the parts record to the curve and then check the yoke field. Next, I will cut the object to the clipboard. And paste it in place inside the 3D component of the first center cell. I use the center cell because the insertion point will align with the original coordinates of the pasted object. Now when I exit the symbol and run the Focus Lighting Devices command on the updated lighting device, you can see that when a pan value is given to the device, the whole lighting device moves as normal. It's now time to test out the lighting device. At the moment, no light will come out of it until we give the light some data. So select the lighting device and click on the Edit button in the Object Information palette. You can see the 3 cells listed, and here you can select all cells together. I need to give the cells some beam angles, and for now I will enter 20 degrees in all 4 fields. I'm going to change the intensity to 300% and then select each cell in turn and add a different colour to each one. Click OK and then go to a front view. There's a quick Renderworks style called Preview Spotlight, which does a fairly efficient job of rendering beams through haze against a black background. What you will notice is that a single beam is produced that is aligned to the insertion point of each symbol and the pivot point of the body geometry. For some multi-cell devices this would be absolutely fine. However, this device has multiple LED emitters in 3 circular arrays. I can recreate that effect using this symbol by adding multiple 3D loci with the parts record attached to each one. So I return to a top plan view, and using the locate symbol in the Resource Manager command from the right-click Object Context menu, I can locate the instrument symbol from the Resource Manager and edit the 3D component. I need to place 3D loci at strategic points within these 3 zones. The placement of these will provide the location for emitters within the lighting device that will hopefully give me more of what I'm looking for. A good way to do this is to place a locus at these 3 locations. And then move them inwards towards the middle of each concentric ring. The next thing to do with the objects selected is to attach a parts record to them. With the innermost locus selected, I fill in the emitter field here with 3, which will correspond to the cell number in the object information palette. I do this 2 more times, and when I have done that, I need to think about how these can be duplicated around the rings. I need to make 2 more copies of this locus in an array about this center point. So I'm going to use the duplicate array command and fill it in like this. When I press OK, a further 2 will be made around this central point. I'm also going to copy this one and place it in the middle. I need to run this command another 2 more times, increasing the amount of duplicates each time, as well as dividing 360 by the number of loci I want to be left with. This will give me the correct angle between each locus. If I go to a front view, I can see the loci at the very top of the body part. I'm just going to move them all down by a few millimeters and click on the Exit Symbol button and return to top plan. Now I'm going to do a test render to make sure that everything has worked okay. And I'm going to use the Preview Spotlight render style again, and you can see that the emitters seem to be working well. To check whether this is going to be okay, I make 3 more test renders, 1 for each color array. I have spent some time modeling the base, yoke and body geometry that will make up the 3D lighting device, and you can see that each one has a parts record attached with the appropriate field checked. The group of objects that make up the body comprise the shell of the body, which was modelled from a sweep object. The second object is a NURBS surface that contains a translucent backlight texture and this will pick up the beams as they pass through it, giving the lens glow effect that you will need. Finally, an extruded polyline which has holes that are aligned to the individual emitters that I placed earlier. All of these objects have been converted into generic solids, which means that the modelling history has been removed. However, this will reduce the file size considerably, and in some cases will simplify the geometry. To simplify the geometry of the face of the lighting device further, you could duplicate this NURB surface and punch the holes using a custom Renderworks texture. All of this is pasted inside the central symbol, and I've removed the temporary NURBS curve that formed the yoke part. If you have planned out the lighting device you are making well enough, then all the geometry should align okay. It is important to think about the top plan view as well. And if I go to the main lighting device symbol, I can edit the 2D component and then run the Create 2D from 3D Component command. It's worth experimenting with the line rendering modes that are available, and I prefer the first one because it gives me a polyline outline containing separate lines. This makes editing the result much easier so that you can tailor the geometry to your own drafting style. When you have finished editing the group, you should send it to the back of the nested objects so that the 3 concentric rings are visible, along with the nested symbols labelled legends. Here are 3 instances of the multi-circuit lighting device in 2D, with the Modify Lighting Device Color option activated in Spotlight Preferences. And here are the completed lights focused and rendered, and you can see that each individual circuit can be turned on and will display on the open face of the instrument as and when you need.